Lesson 15 demo. Today we expand our ability to use the chain rule to differentiate functions defined numerically and compositions of more than two functions. We also learn that dogs do calculus. 1. Sometimes we have to apply the chain rule repeatedly. In the process of evaluating the derivative of stuff, we might have to use the chain rule again. Let's take a look at number 2. It says find the derivative, e to the sine of 2x minus 4 to the third. Okay, quite complicated. Let's start by writing our y prime equals. So fundamentally, this is e to some stuff. And we have a rule for the derivative of e to the x. It is just e to the x. We saw it informally last class. We're still going to deal with it informally today. But if the derivative of e to the x is e to the x, then shouldn't the derivative of e to the sine of all that begin e to the sine of all that? So this feels like a reasonable start here. E to the x becomes e to the x, then e to the sine of 2x minus 4 cubed should become e to the sine of 2x minus 4 cubed. However, we didn't just have e to the x, we had e to this complicated thing. And so we're going to put the derivative of that complicated thing right in here. And so what's the derivative of sine of 2x minus 4 cubed? Well, derivative of sine of x, we saw informally last class, was just cosine of x. So then the derivative of sine of 2x minus 4 cubed should be cosine of 2x minus 4 cubed. However, this derivative rule would have been good if it was just sine of x, but it wasn't just sine of x. It was sine of something more complicated than x. So now this thing needs its derivative recorded. We're going to record that derivative right there. So sine of stuff became cosine of stuff times the derivative of the stuff. Okay, let's take a look at 2x minus 4 to the third. That's stuff to a power. I know how to handle stuff to a power. The power comes down. I need to make this circle a little bit bigger. The power comes down. You copy the stuff one time. You subtract 1 from the power. And then you multiply by the derivative of the stuff. Well, the stuff has changed roles a number of times in this problem, but right now the stuff is 2x minus 4. And so the derivative of 2x minus 4 is going to go right in there. And the derivative of 2x minus 4 is 2. And that's the end of this problem. So this one really is kind of like one of those old-timey telescopes that it's a small thing in the beginning and then you sort of unwind it. In this case, we had e to some stuff, and so that became e to the stuff times the derivative of the stuff, and then the derivative of sine of stuff is cosine of stuff, but then we had 2x minus 4 to the third instead of just x, so the derivative of that was another chain rule. The 3 came down, we copied the 2x minus 4, we subtracted 1 from the power, and then finally multiplied by the derivative of the stuff in the parentheses. So just be really careful as you're multiplying by the derivative of the stuff. Technically, it's only, the derivative one time. Chain rule says multiply by the derivative of the stuff one time, but it happened that this particular problem involved several nested chain rules. Okay, number 3, given the table below, find the indicated derivative at x equals 1 if possible. Write CBD if the derivative cannot be determined. So I've got a table. I don't quite know what to make of it. The x values are 1 and 2, and then I'm given information about f and f prime and g prime. We'll come back to that when we're ready. Okay, so this is saying find the derivative of this complicated function. All right, so the first one, so first thing I see actually is this minus sign. I'm happy with that minus sign. That minus sign says I get to take two separate derivatives, two independent derivatives, and subtract them from each other. So that's the first step. Now I'm ready to look at the first piece of this. So f of x cubed, that's what I'm after right now, taking the derivative of that. So I will highlight the f of x only, and I will point out that currently this thing is stuff to a power. It's stuff to the third power. F of x is my stuff in this case. And so when I see stuff to the third power, I know that I'm supposed to bring that power down. I'm supposed to copy the stuff one time and subtract 1 from the power. Let's go ahead and write the stuff in here. It is f of x, highlighted in yellow again. But then the chain rule says after you've applied the power rule, you then multiply by the derivative of the stuff. Multiply by the derivative of what's highlighted in yellow. What is the derivative of f of x? This is just symbolic. The derivative of f of x is called f prime of x. That's the answer for the first part of this derivative. So again, this was some stuff to a power. Power came down, copy the stuff, subtract 1 from the power times the derivative of the stuff. It's just symbols. Minus. Okay, next thing I see is a 5 times something complicated. Okay, I'm happy with that because I know constant multiples get copied down when I do a derivative. So now we're ready to look at that g of x to the third plus x squared. So I'm going to highlight this stuff inside the parentheses. So the form of this derivative is g of some stuff. Let's take a step back to this example up here. And I'll look again at this rule that we don't quite know yet, but we'll see it soon officially. But the derivative of sine of x is cosine of x. And over here we applied that rule, but it wasn't just sine of x. It was something more complicated than sine of x. It was sine of some stuff. And so when we did the derivative of sine of stuff, we wrote cosine of the stuff, and then times the derivative of that stuff. So the derivative of sine of stuff became cosine of stuff. Sine of stuff became cosine of stuff, times the derivative of the stuff inside. Same deal with e to the x. The derivative of e to the x is e to the x. So the derivative of e to all of this stuff was e to all of that stuff, but then times the derivative of this stuff. So the point of looking at this again is just to show you that regardless of whatever like the basic rule is, all right, the outer function here is sine, outer function here was sine, and then we had this inner stuff. So you apply the basic rule, the derivative of sine became cosine. So we're going to apply our basic outer function rule. What is the derivative of the outer function? Well, the outer function is g, and so symbolically the derivative of g is just g prime. Now, what am I supposed to do with this thing in green? Well, that's the stuff, and we always copy the stuff intact one time when we do the chain rule. So when I see g of stuff, I say, okay, the derivative of g of stuff is g prime of stuff. So we copy that stuff one time in the parentheses, but then times the derivative of the stuff, times the derivative of what's highlighted in green, and the derivative of x cubed plus x squared is 3x squared plus 2x. I know that that step right there is going to be a reach for some of you. I'll tell you, when I took AP Calculus as a senior in high school, this was a reach for me. Okay, that's actually complimenting myself where I could not do this when I was taking this class. So I'm hoping that you get to a better place than I was when I was in your shoes. So one more time, we're thinking kind of about outer and inner functions here. The outer function was g, just like the outer function up here is sine. The derivative of sine is cosine. And then after you've written the stuff one time, you multiplied by the derivative of that stuff. The outer function here was g. The derivative of g is just symbols. It's just g prime of the stuff copied one time times the derivative of the stuff. Okay, so now I think we're ready to evaluate this someplace. What do we do? It says find the indicated derivative at x equals 1. Okay, so now let's evaluate at x equals 1. I don't want to copy all that again, so I'll just call it y. And then remember, this is our notation using Leibniz's version of things. And so all we're doing is copying our answer, but every single x becomes a 1 in this case. So 3 f of 1 squared times f prime of 1 minus 5 times g prime of 1 cubed plus 1 squared times 3 times 1 squared plus 2 times 1. Every x became 1. Okay, very carefully going through here. 3 times something squared. Oh, okay, finally I'm ready to use my table. F of 1 is given in the table. It's right there. It's 1. So that's a 1 squared times, oh good, f prime of 1, that's also in the table. F prime of 1 is 3 minus 5 times g prime of, okay, I have to do this arithmetic before I use my table. 1 cubed is 1 plus 1 squared, that's another 1, that's a 2. I'll use the table in a second. Times 3 times 1 squared is 3 plus 2 is 5. So one last look at the table for g prime of 2. That is way out here. That's 7. So this equals 3 times 1 squared times 3, that's 9, minus 5 times 7 times 5. Okay, so that's 9 minus 25 times 7. I think that's 175. Hope I got that right. Negative 166. Okay, so negative 166 is our answer there. Remember, before you plug in the ones, you got to do the general derivative for x. Okay, number 4. Here are 3 versions of the chain rule that all say the same thing. Version 1 in English. To take the derivative of a composition, you take the derivative of the outside function, evaluate it at the inside function, then multiply by the derivative of the inside function. I'm going to point out that we did that more than twice today. I'm going to point to 2 places. Sine of stuff. Derivative of the outside, that's the sine. Derivative of sine is cosine. Evaluated at the stuff, we copied the 2x minus 4 to the third there. Then times the derivative of the stuff. The derivative of 2x minus 4 cubed was big. It's all over there. We did the same thing in this harder one with the g. It says you take the derivative of the outside one. G became g prime. Evaluated at the inner function, right there, times the derivative of the inner function, right there. So that's the English version of the chain rule. I want you to know that one. Then there's this mixed notation version. So derivative of f of g of x, there's our composition, outer and inner. That's what we're thinking of. It's f prime times g of x, sorry, f prime of g of x times g prime of x. And you should convince yourself that that says the same thing as the English version. It's the outer derivative evaluated at the inner times the derivative of the inner. Okay, and then Leibniz's notation, dy dx equals dy dz times dz dx. That should not make a whole lot of sense at this moment, but you'll practice with it in the activity. But if you allow me to treat these things as numerical fractions, and you let me cancel these dz's, then of course dy over dx equals dy over dx. So it does have that going for it, but you'll make some more sense out of it in the activity.